Good morning to everyone. I'm Saipon from CSC Department of AML and of pairing rule number 23951A66F7. And today I'm here to discuss about the integrated expert knowledge into fuzzy reinforcement learning, the subject of applied artificial intelligence. And without any delay, let's get start our session. Introduction. Reinforcement learning RL learns from rewards and penalties, and fuzzy logic handles uncertainty in decision making, and generally, this reinforcement learning combines RL with the logic and enhances adaptability. And expert knowledge helps define fuzzy rules for learning. This generally objective explore integration of expert knowledge in fuzzy logic reinforcement learning. And this in this diagram we can able to see the layers of the machine learning and artificial intelligence like reinforcement learning, deep learning, supervised learning, and unsupervised learning. Generally, supervised learning is also known as labeled learning, labeled data, and unsupervised learning is also known as unlabeled data. And background on background on reinforcement learning. These reinforcement learns by interacting with an environment with the key elements like state, action, reward, and policy. This requires large data for training and tuning. Generally, this struggles in dynamic and uncertain environments. These fuzzy logic and reinforcement learning improves adaptability by using fuzzy logic and fuzzy systems. Fuzzy logic deals with degrees of truth, not binary values. Uses fuzzy sets and membership functions. Fuzzy systems are fuzzy rules if and then define decision making while in the which helps in the algorithm. Fuzzy interface system maps inputs to outputs, and fuzzy logic and fuzzy systems used in control systems like robotics and decision support. And in the diagram, the expert system, which is combination of rules engine like user interface and knowledge base. In the diagram, non-expert or user is a sample input which is gained knowledge from an expert system. And why integrate expert knowledge into fuzzy logic reinforcement learning? Generally, this integrated expert knowledge helps when data is limited or uncertain. It also domain experts define initial rules for better learning, reduces trial and error methods, and the speed up the training. This intergate expert knowledge makes AI decision more interpredictable and combines artificial intelligence learning with human i- interaction. Fuzzy reinforcement learning (FRL) overview is generally FRL extends RL and with fuzzy logic and uses fuzzy sets instead of discrete states. Fuzzy Q learning improves decision making, and fuzzy reinforcement learning and handles continuous state space better, applied in robotics, finance, and adaptive systems. In the diagram, we can able to see knowledge base, inference engine, and interface. Human expert, knowledge engineer, user may not be an expert, and methods of integrating expert knowledge into fuzzy reinforcement learning. Rule-based initialization. Experts define initial fuzzy rules and human in the loop learning. Experts refine RL strategies like fuzzy reward shaping, expert influence reward structures, and etc. And adaptive membership functions like dynamic expert tuning and hybrid models. Generally, these hybrid models works on combination of rule-based and data-driven approaches. Challenges that we often face in expert knowledge integration while using RL fuzzy logic, conflicting rules from different experts, too many fuzzy rules, car slow learning, hard to balance generalization versus specificity, and it is also difficult to modify expert rules dynamically, whereas risk of humans bias in knowledge encoding. In the diagram where we can see user is in a query with user interface, in inference engine and knowledge base, and expertise guiding the user on advice of knowledge base. And approaches to overcome these challenges are neurofuzzy models. These neurofuzzy models generally works on neural networks which which define fuzzy rules. Eleven evolutionary algorithms optimize fuzzy rules helps us to overcome such challenges. Active learning. Generally, the term active learning is selectively consults experts. Hybrid AI, which is also known as combines of any two AI systems like expert system with deep learning and fuzzy expert. Explainable AI, which makes fuzzy reinforcement learning decisions interpretable. These are the some of the approaches where we can use to overcome these challenges in reinforcement learning. And generally, the fuzzy logic is a logic or an approach to variable processing that allows for multiple possible truths values to be processed through the same variable. Applications of expertized enhanced fuzzy rules, autonomous vehicles, adaptive driving strategies, and it also uses in healthcare like AI-driven disease diagnosis and smart manufacturing like process optimization, and it also uses in robotics where motion control in complex environments and finance like market trends prediction with uncertainty modeling. Future research directions. Deep fuzzy logic combined deep learning and fuzzy logic. Human AI collaboration, experts and AI refining rule together, federating distributed knowledge sharing, uncertainty modeling, like handling high variability data, etc. And while coming to the conclusion of this session, we can after this session we can able to get the knowledge on expert knowledge enhances RL in uncertain environments, and fuzzy reinforcement learning improves interpretability and adaptability. Integration challenges require hybrid AI approaches where future research will focus on deep learning and scalability. And future of expert systems in AI in artificial intelligence are increased automation, improved decision making, enhanced customer service, integrated with other AI technologies and challenges. And thank you. If questions are open for discussion, thank you.